So welcome everybody to this webinar on finding performance requirements using barrier analysis. This is I think around 30 minutes webinar, and I don't think we'll do the hour that was in the schedule, but so we have plenty of time. I try to keep them at like a half an hour. It's a nice format. Before we talk about performance requirements, I want to zoom out a little bit first and talk about the bigger picture. And then what we'll do is make our way down until we get to actually finding what is a barrier performance requirement, why would you want one, and how do you do it. So I want to start off with this picture. This is a very high level picture on what is essentially risk management. And I think it's good to start here because it just paints the entire, let's say, the big picture, and then we sort of place where barrier performance and performance requirements, where they play a role. So this is a, let's say, double circle picture. So there's like this green circle thing, and then there's this blue circle within it. This is the normal, let's say, risk management life cycle. You start off at the top there where you see scope, context, criteria. So if you're doing any type of risk assessment or risk management, you need to know, like, who are we doing this for? Why are we doing this? Like, what is the scope? How many sites or vessels or activities are we including? To sort of know what we're going to talk about. Then you see the next step in there is identify risks in this green circle. You want to know, like, what are all my hazards, and how can, like, what is the, let's say, the long list of things that can go wrong. Then you want to analyze those risks in more detail, seeing like what are my barriers that I have there, what can actually, how bad is it if it goes wrong. And then you want to evaluate the risk to sort of say, like, okay, given what I have in terms of barriers and controls, do I have to mitigate my risk? If it's not low enough, you need to do something about it. Then you treat the risk, and then hopefully at some point you're happy with the situation. You have enough controls and barriers in place to mitigate your risks down to an acceptable level. And then you can start to maintain what you have. So you've arrived, like, execute maintenance to upkeep your technical and behavioral barriers. And then, very importantly, you verify barrier performance. So you want to sort of make sure that your barriers are, let's say, alive. And then you want to say, do they actually meet the performance that I expect from them? And if you identify structural degradation, that's the top part of this blue circle, then you go back into the design and change loop, where you basically figure out, like, is this really a problem? How big is the risk? Do we need to treat it? And sort of make a real change to your system. If not a structural degradation, but just let's say normal degradation, then you just execute more maintenance to get it back to a normal performance level. So then you basically stay in the blue circle and just maintain what you have. That is sort of, I think, at a high level, what risk management is like, in the first place, designing and changing your operation and your organization in a way to mitigate the risk. And then you go into this maintain cycle where you just try to keep things at the same risk level. Okay, so the step, so there's only one step in this bigger picture, but it's very important, of course, and it's very tricky, because how do you know that your barrier is doing okay or is not doing okay? How do you measure that? And so that's what the topic of today is about. This is another way to visualize the same thing. So initially, over time, you go into, like, building up, let's say, a new site or a plant or an operation. You start to implement all of your barriers, and then at some point you go into operation and you start to maintain what you've built. And then maybe that over time the barrier performance starts to degrade. So you can see sort of more things where your barriers are not meeting the standard that you set for them. There's a really nice standard that I've used a little bit as inspiration for this webinar. It's the critical control management document from the ICMM. So if you just Google ICMM and then critical control management, you'll find it. It's available. They've got a really nice description of how to do critical control management in the first place, which we have other webinars on what that is exactly. But then within that standard, there's also a nice section that talks about how to set up performance requirements. So I just want to say that as like, if you want to dive into it more, that is actually a great document to take a look at. So what is the core of a performance requirement? So if you have a more, let's say, simple barrier or a barrier that you think doesn't deserve a full-blown analysis, this is, I think, what is the, let's say, the more bare bones components would be to say, what is the barrier trying to do? What is the objective of the barrier? That is nice to know, like what is actually the goal, for instance, energy isolation. This is from the ICMM standard, to prevent exposure to fatal energy source by ensuring they're all isolated, locked out, tagged out, and verified as isolated. So that's like what a controller barrier is trying to do. Then what is the target performance? So what do we expect in terms of the performance? So for instance, for a fire monitor, you intend to disperse some, let's say, water at a particular amount of time, right? So you specify like there's a flow of water for a number of minutes, and that's sort of what your target performance is. And then a performance trigger, where you describe what is the threshold for action. So what is my acceptable limit for when I need to take additional action? So what do I consider a degradation in the performance? This can be quite tricky. So let's say, how many cases of the barrier not meeting its performance of its required performance in a given time window, for instance. I think those three things, if you think like what they're supposed to do, what does performance look like, and at what point do we take action when the performance drops below a certain level. I think if you think about those three components, then you have, let's say, the core. But in a lot of cases, the barrier requires a little bit more in-depth analysis. So this is why you can use barrier analysis. Barrier analysis is something we introduced in RiskRunner, which is the software tool that we'll use for this webinar as well. It's the tool that we make. So in most, let's say, most barriers, you would say, is a combination of behavior and/or technology. So if you have a fire suppression system, that can be a purely technical barrier. It can also be that you have, let's say, a fire watch combined with a sprinkler system that will be a combination of behavior and technology. And so you could argue that all barriers are, let's say, a combination of some type of behavior and/or technology coming together to create a barrier system. And then we have to do stuff to implement and maintain those barriers. So there's maintenance we have to do, maybe there's training, you have to keep up your inventory, you may have to do some planning. There's all these, let's say, the supporting layer underneath a barrier that makes it work. And this is what we want to analyze in depth. So if we say like, okay, we are fine with just describing, we have a barrier and we describe like what is its purpose, what does performance look like, and what is the trigger for when we take action, that's sufficient, then that's fine. But there's, in a lot of cases, this underlying layer that you also want to analyze in terms of like, what is all the supporting things that we do. And so for that, we have barrier analysis, and I'll show you a minute in the software with an example. So we've broken a barrier, or let's say the underlying components of a barrier, down into two main factors. The degradation factors and barrier components. The degradation factors is everything that will make your barrier less reliable. So it will basically anything that will defeat or reduce the reliability of your barrier. And then barrier components are the positive side of that. So anything that is about implementing and maintaining your barriers to increase the reliability. Let's give you an example first before we move on. So here I have an example. This is a bow tie on a tank with the hydrocarbons. Make it a little bit bigger. And I have a loss of containment here for this tank, and that can be caused by some overpressure, overfilling, corrosion. I have some consequences on the other side, pool fire, vapor cloud explosion. And then there's some barriers in between. So let's take a look at, for instance, the high level alarm. So for the high level alarm, I've got a description here, if I click on it, to say what is the objective of this barrier, what is the target performance of it, and what is the performance trigger. So when do I want to take action? And that's sort of part of this barrier definition. Let's say what makes this barrier is just this description of what is it supposed to do, what is the performance, and the trigger. This is a relatively simple barrier, but I've still got some underlying analysis on what makes this barrier fail. So I've got, for instance, I'll zoom in a bit. The high level alarm is stuck in place, and then there's things I can do underneath to make sure that that doesn't happen. So I have visual inspection, visual maintenance. These are, let's say, the supporting activities that make sure that this is not a problem. Same thing for corrosion. I have maintenance and visual inspection to make sure that that is not a problem that is affecting my high level alarm. This is, I would say, already one level more of analyzing your barrier and saying like, okay, what is all the things I need to do to make sure that my high level alarm keeps working? Slideshow. But this barrier analysis allows us to have multiple styles. So I can also have a simple list with just supporting activities. So I basically just have a bunch of those. I have a barrier, and then I list underneath what are all the things that I need to do to make sure that this barrier is working and is implemented. I can then, even in this middle section, go one level deeper and say what are all the verification activities that I do to make sure that my supporting activities are all done. So I basically add another layer. And the one I just showed you is this more classical style, where you first try to figure out like what are all the factors that are making my barrier fail or break them, and then how do I make sure that that doesn't happen, that those factors are, let's say, neutralized. All are valid in that they're just different styles in figuring out what are all the things I need to do to make sure my barrier keeps working. Okay, so here's a fall arrest harness example where I have a fall protection, and then also a review on that program to basically verify that that program is still valid. Then I have some inspection on the harnesses and some purchase and storage. Let's see here, I'm working at height. To show you here, so that this is what that would look like. Oh, sorry, wrong button. What it would look like in the software. So I would say I have my fall arrest harness here in another bow tie on work falling from height. And so I see underneath all the components that I need to do to make sure that this barrier keeps working. Okay. That's another, it's a more direct, I would say, if I had to give advice, I would say to people, to start off with this more simple style of just saying, I have a barrier, and then underneath that barrier, I have a list of things I need to do to make sure that that barrier keeps working. And then you can sort of do these more, the degradation factors. So, and then that style, the more traditional style, you can do if you really see like, oh, there's a problem with this barrier. It's sometimes it has issues and we need to solve those issues. Then you can go for this style. But I think the default is probably better to just identify what are all the supporting activities for my barrier. Okay. There's another one. This is also described in the ICMM. Not exactly in this way, but the idea is there. If you have a really complicated barrier, to also deconstruct or decompose this barrier into subcomponents first, and then for each subcomponent to then break it apart. So if you have a really complicated barrier system, you could use this detect, decide, act, let's say, concept to break it apart. So the question would be like, what is the detection mechanism in this barrier system? How does this barrier make decisions? Is it like some type of logic gate, or is there a person there? And then what is the action that follows the decision? In a lot of cases, the decision is actually implicit in the action, but like theoretically, it's part of this deconstruction. So you can break apart the barrier into these subcomponents first, and then for each one of those, you're going to find the supporting activities for the individual components. So here's an example for a fire suppression system. You could argue that this is the overall barrier system, but it breaks apart into, let's say, smoke detectors. This is the detect part. The fire alarm control panel, which is the logic gate, let's say, for the decision. And then the CO2 system is the action that follows it. So I've basically broken apart this barrier first. And then for each part, I'm going to analyze it further. So in this case, I know there's some problem with dust accumulation for smoke detectors. So I have some smoke detector maintenance. And then here for the fire alarm control panel, I have a direct, let's say, activities that I do that are supporting and also verifying. And then for the CO2 system, I know there may be a CO2 leak, so I have some CO2 leak testing. This I think is the, let's say, most elaborate version of breaking down a barrier into its subcomponents, so that we know exactly like what does performance look like for each individual subcomponent. Okay, so let's say if we want to monitor the performance, so we've got basically a detailed breakdown of everything that we expect our barrier to do. We've listed what does performance look like. So what is the target performance we expect? What is the trigger? Now it's time to start monitoring it. So when you think about monitoring, one of the things that you want to be careful about is overloading people with questions of like, hey, what's the performance like? What's the performance like? And to sort of add to their administrative burden. One of the ways that you can reduce that load is by taking a look at how often do you check? How often do you verify the performance? And how often do you verify the requirements are met? If you have so in this case, we've basically looked at two variables to determine how often we need to check something. One axis is criticality. So how important is a barrier in a scenario? Let's say if you have a key control or a critical control, those are the controls that if they don't work, you have a really big problem. But there's also controls or barriers that are there in addition, or like they're really redundancies that if they do not work, it is less of a critical issue, right? So you can make this distinction, like what are important barriers and what are just contributing barriers. The other axis is variability. So whether something is very low or more static, like let's say a dike. it doesn't change much. It sits there and it's sort of there, versus something that is very dynamic, and it can change quickly. The performance of it can change quickly. Then you want to check it more often. And so combining these two things, you can say, well, if it's very important and it can degrade quickly, so the performance can degrade quickly, then we may want to check monthly. If it's important but it won't change that often, we can do quarterly or even yearly if it's low. And then for the other extreme, if it is not that important of a barrier, it's really a redundancy, and it's very static, then we can say, oh, we'll just check it 5 yearly, and that's enough. And this basically ensures that you spread the load of how often you check. Okay, so in Risk Runner, we've got something for this called a review schedule. So the idea behind reviews is that you can ask people to give updates on, in this case, the performance, like how well are the barriers performing. And then we've also got schedules. So you can add a review schedule and say, I want to do my barrier performance verification. And I'll make it a fields one. And in this case, I need to sort of select what am I going to do in this review. In this case, I want to check the performance of my barriers. And I want to not do this for all barriers. I just want to filter it because I've got some variables here to say, like, what are my critical barriers? And I want to do this for the dynamic critical barriers, basically barriers that can change quite quickly, but are still also very important. And that will crop the list down, and I can say these are the ones I may want to check every month. So I will set a review date. First one that will be tomorrow, gets 5 days. And then recurrence is once per month, and it ends never. And I have to do it. So this will now create a schedule for me to check these barriers at a monthly interval, to sort of update the performance. Now this will start running. It will send me an email tomorrow, and I can see now I've got like scheduled reviews every month for the foreseeable future. Let me actually quickly add one more so I can show you what it will look like once it starts sending out. Performance review. Performance. Filter it down to the same amount. Include those. Next. Sorry, I just wanted to also show you what it would actually look like to do this performance requirements review. So here, the current performance is good for the pressure safety valve, let's say. Oh, sorry, the high level alarm was my example. That's actually currently good. If I click on it, I'll be able to see what's the objective, what is the target performance, and what is the performance trigger. And so based on, but I don't have a lot of other things to go on. I can sort of try to take a look here at the definition. And there I'll also see the barrier analysis underneath. And sort of say like, given what I'm seeing here, I'll just say, I know what the status is. It's still good. Oh, let me change one thing because I forgot to forgot one thing that I should have turned on. Which is the performance. Okay, let's take a look at this fire suppression system. So this fire suppression system was the one that is a little bit more elaborate. So here, if I go to the definition, I'll actually see the full breakdown of this barrier. So I'll see the smoke detectors. So the performance all looks good, but this smoke detector maintenance is actually has a performance of poor. So there's in this, let's say, breakdown of performance, one of the subcomponents, the performance of it is poor. So if I click on that one, I should see it. Okay, let me actually do it this way in that case. So I see here the smoke detector maintenance, and that has a history where it actually the performance is poor. So I can see here, if I hover over it, that the maintenance has been deferred again for this smoke detector maintenance. So after a little bit of digging, I can find like, oh, it's actually this overall performance for the fire suppression system is good, but there's this thing underneath that is the maintenance on the smoke detector is actually poor. So I'm going to say poor because of deferred maintenance on smoke detector maintenance, yeah, on smoke detectors. Finish. So then I've now sort of set the performance of my barrier, updated that to sort of a new value. So now, if I take a look at the tank with hydrocarbons, and I actually show the performance, I'll be able to see, oh, the fire suppression system performance is actually poor. If I show here, I can see, okay, this is actually all good, but the full analysis is showing me that this smoke detector maintenance is poor. So that's why the overall performance of it is poor. Now, this is still, let's say, what I've shown you so far is basically, okay, you can make a barrier. In the description of this barrier, you can define like, okay, what is the objective of it? What is the performance that I expect from it? And when do I trigger a action? Like, when do I say like, okay, it's now poor, we need to do something? And then for the more complicated barriers, I can sort of make a full breakdown of this more complicated barrier. And then also have performance for each one of the subcomponents, so that if a subcomponent breaks down, then it can sort of trickle up to the main barrier to sort of say like, okay, this main barrier is now no longer performing well. What we are working on in the future is, or for the next version, is something called signals, where people will actually be able to give input on the performance. Let's say you can collect input on the performance from many people, and they can say like, okay, this barrier is actually working well or it's not working well. So when we do this updating on the barrier performance, you can have this side panel where we can say, oh, these are all the verification signals that have come in from people that have said like, oh, this barrier is working well or it's not working well. Same thing for the observations, where we can say, okay, there's actually this many incidents where the barrier failed or it was inadequate, for instance. And so based on this supporting evidence that we've collected, we're going to adjust the barrier performance. So not just based on the underlying barrier components, but also based on, let's say, signals that you've collected from the organization. This is coming later in the year, around Q3. So hopefully we'll be able to tell you a little bit more on this part later on. And then I think that was it for the performance requirements. Are there questions? If it's too fast in parts, then I can like reiterate some parts of it.
That was very clear, Alex. Thanks.
Okay.
I like Hell 9000 in the signals.
That's my test user. Okay, if there are other questions, you can put them in the chat, or also after the webinar is done, please contact us afterwards as well if you want more info on particular parts of it, or how to set up, let's say, performance requirements or critical control management. I know this may have been like a fast, let's say I went over it quite fast perhaps. So if you need more details on parts of it, just let me know. Then for now, thank you very much for your time. And then I hope you all have a very wonderful day. See you later in the elevator.
Max, thank you. Bye-bye. Bye, Paul.
Thank you.